welcome back. We're continuing with our introduction to C++ programming and our dungeon crawl videos, but I want to take a little step back from working on the actual dungeon crawl and go over some concepts in C++ that will be very useful to us. And when I sat down looking at the dungeon crawl code and how I was going to use these things, I decided it would be better, easier, perhaps for you to understand if I explain the concepts, programming concepts first with some examples before we dive into making use of them. So that's what we're going to do now. So what we're going to do, if you're following along and creating projects or creating solutions, I'm going to create a new solution here. I'm going to come down here to create a new project in Visual Studio, and it's going to be a console app. So just a reminder, we're selecting C++ and Windows console, and this is a console app here for C++ Windows. Click Next, and I'm going to make sure that this is in my CPP projects folder. I'm going to browse, and under video, I'm going to select that folder. And of course you can organize this however you want. This is just for my video organization purposes here, keeping some things straight. And I'm going to call this, I'm just going to call it functional concepts. And we're just going to then create this project. And we're, let's take a few seconds here. Here we go. We've got our main function. Now, what I'm going to do is we're going to be building some very simple template functions to demonstrate some concepts in how we can act upon lists of things in a very generic fashion. We're going to use templates to do that. So I'm going to just create a header file only here. So I'm going to click on my filter called headers, and I'm going to go add new item. I'm going to select header file. I don't have a special template for putting that in, but that's not a big deal. So this particular header, what we're going to call it here is, let me double check what I called it. I think I just called it list. I do believe, yes, I called it list.hpp. Okay, that's good. List.hpp. And this is just going to contain some function declarations and their implementation, but they're template functions that we're going to be creating. So what do we want to do here? All right. So for the first one, we're going to do some very simple things with the ideas of templates here. We're going to create a template. So we're going to type the keyword template, and we're going to have a type name T for this template function. And this is going to return a list. So we need to pound, let's see, oops, typo, hashtag include list. And we're also going to include functional, and we're going to include tuple. We're not going to be using these right off the bat. Some we may. Functional and list we will. Tuple we'll use later. For this first function, we want it to return a list of type T. This is where our template function stuff comes into play. We're going to be giving it the type of the elements of that list, and we're going to call this function map. And to map, we're going to send it a standard list of type T, and we're just going to call that list. And then we're going to send it something else from functional. We're going to send it a function. Now this is where it gets a little bit weird. So I'm going to put those two there. I'm just going to call this func. And this is a strange syntax, it seems, but this is function, we've got to give it a function signature, which is something that returns a t and accepts a t as a parameter. So this is a template parameter that is also a function type. So it returns a t and accepts a t. So we pass a type t into it, and it returns a type t as some kind of anonymous function. Oops, I missed a colon there, didn't I? There we go. So there's what our function looks like. Now, what does this function we call map do? What the idea or the concept of map is that it takes a list and it takes a function and it calls the function on every element of the list, passing each element individually in as the input parameter, takes the output parameter, puts it into a new list, and returns that list as the result. So it takes and maps a function onto a list. So let's see how we do that. So first of all, we're going to need a list of type t that will be our result. Then we need to loop over it. So we're going to use this for t item colon list. So what does that do? This formulation of for works on lists or other types of things that have iterators, and it iterates each element of this, assigning it to item, which is of type t. Then all we're going to do is go result dot. Now lists all have this pushback function, and we're going to push back the result of calling func on item. And then we're going to return our result. So what this does is it takes in a list here and a function. It creates a result list. It iterates over all the elements in list, and it pushes into that result the result of calling the function on the item for every item, so that we end up with a list of results. Let's see how that works from our main function. So the first thing we're going to do up here is include our list.hpp. We're going to get rid of this hello world, and I'm going to get rid of all this garbage down here. You've seen that before, and you can read it in your own Visual Studio if you want. So the first thing we want to do to test this is create a list to be some input data. So let's do a standard list of type int for simplicity, and we'll call this int list, and we'll initialize it to 1, 2, 3, 4, 5, 6, 7, 8, 9. Oops. And that in a semicolon. And now we'll create another list, standard list int, and we're going to call this int result equals, and we're going to call our map function. We're going to pass in int list, and we're going to pass in a function. And the way we create a Lambda function in C++ is we have to give it a what's called a capture list. In this case, it can be empty. We're not trying to capture anything into the function from outside the function. And then we have to have a parameter list. And this parameter is going to be of type int that we're going to pass into it. And then we have a function body between braces. And in that function body, let's do something like return. Oh, we have to give this a name. We'll just call it I for simplicity. We'll return I times 3. And why doesn't it like it? Oh, well, because we have to tell it int. There we go. So this is how we call that. We're creating a list of int called int result. We're calling map of type int. That's our type that's going to be in our list. We're passing in the int list up here, and we're passing in a Lambda function. And this lambda function is has nothing in its capture list. We'll talk about capture lists in another concept, in another context. The function takes an I as an integer by name of I, and it returns I multiplied by 3. So now let's just loop over it and find out what that does. For int item colon int result. And we already have IO stream included, so I'm going to go standard cout from item from standard and L. And we'll just run this. And there's the output. 3, 6, 9, 12, 15, 18, 21, 24, 27. So we did this on integers, and understand that it doesn't have to be an integer. In fact, it doesn't even have to be a basic type like a float or a character. It can be objects of another class, and our function could be going through and adjusting everybody's pay up by 10%. Oh, I know, that's a pipe dream. No company's ever going to write an algorithm that does that. But we can pretend. So what int is doesn't matter so long as this is doing something appropriate to what that is and knows about it and understands it. And we'll see some examples of that. This is how we're going to process user records and other things with functions like this. Let's go back to list now, because we're dealing just with lists, and think about another type of function. Another type of function is called a filter. Now what a filter does is it takes in a list and it returns a list that could be the entire input list or some subset of the input list, having filtered some things out. Anything that does not meet the criteria of the filter would be rejected. And so now we'll explain how this filter concept works on a list of things. We're going to again return a standard list t. We're going to call this filter, and we're going to take a standard list t called list. This time we're going to take a function that's a little different. This function that we're going to call filt is going to return a bool, but take as an input a t. Oh, and I forgot to put my template up here. Template, type name t, so that it knows what t is supposed to be. So now what are we going to do? Well, it's very similar. We're going to create a list t. We're going to call it result. We're going to go for t item in list. And now we want to make a decision. We're going to say if filt item. So we're going to pass each item to this filter function that we pass in, and if it returns true, we're going to go result.pushback item. And then, and then down here at the bottom, we're going to say return result. So what this does is this function is a decision function. It's going to check the item and see if it's something that should be included. And if it should be included, it should return true, in which case it'll include that exact result in the output list. Otherwise, if it fails it, it won't include it in the output list, and we will have filtered our list. So let's take our int list and let's create another, here we'll call it standard list int, and we're going to call this filt result equals filter, And let's use the int result that we created there, having passed it through the map function. Let's take that in. Let's create a lambda function. This lambda function is going to take in an int called item. And actually, let's call it that up here too, just for clarity. Instead of using I, let's call it item and make this item times 3. Item, and then we've got the body of the function. And let's say we return, return item is less than 10. So this is saying I only want the items whose number is less than 10, and why is it giving me error and filter, int result. Oh, again, I forgot to put, got to tell it that it's an int. Okay. Int result, int item, return item is less than 10. This will filter out anything that's 10 or greater. So we can just copy this and make a few mods here. We'll make this filter result. And let's put some labels above these so we can tell them apart. Let's go standard cout from, we'll call it int result. Just so we have a division between them, and I'll copy this, put it down here, and call this filter result. And let's run this and see what we get. So under int result, we get the 3, 6, 9, 12, 15, 18, 21, 24. On this, we just get 3, 6, 9. Let's do something a little different. Let's modify it. And instead of asking for the items that are less than 10, let's say item modulo 2 equals 0. And run that. Now we get 6, 12, 18, and 24. Out of this list, these are the only ones that were even. How about if we make this does not equal 0? Oh, and if you're wondering about that, I may have told you this before. I've got a special font loaded into this that allows me to get mathematical symbols displayed. In reality, this symbol is in fact 2 characters. It's not equals. When they're put together, my system turns that into a not equals math symbol. It's kind of cool. It makes things easier for me to read, but if yours doesn't do that, don't worry about it. So let's run this, and they should all be odd now. 3, 9, 15, 21, and 27, all the odd ones. Okay, and one more concept, and then we're gonna change modes here a little bit, and I'll explain that in a second. And for this last concept, I'm going to talk about, this is called zip, and this is where the tuple comes in. We included that up here, the tuple. So we're going to create a function. It's going to be a template again. Oops. Type name T. And it's going to return it's going to return a standard list that is a list of standard tuple. Oh, type name T1, type name T2. So zip is going to take 2 lists of different types, and I'll explain that in a second. This returns a tuple of type T1, comma, T2, T2, and we're going to call it zip, and we're going to take in a standard list of type T1 and a standard list of type T2, and we'll call this list 1 we'll call this list 2, and then no, there's no need, just those 2 lists. What this is going to do, so what is this going to do? Zip is going to take 2 lists. They have to be of equal length, or they should be. Actually, it can only return the combined lists of the shorter of the 2 lists in length. That's the most it will combine. So, we'll think about that. They really should be of the same length, but I guess it's not absolutely required as long as you know what's going on with it. Now, to do this part, I have to do something kind of special here. What we need to do is create a couple of iterators on this. We need to move through each of these lists simultaneously. And it's just, it's a little bit easier than doing the for loop, and I'll explain why down the road here. For now, what we're going to do is create a couple of iterators. So we need to say type name here in order to tell the compiler that we're working with a type here called iterator. That iterator isn't a field of this. Oops, I missed this. What this type name here says is this is a type, not a field. So when it's creating this this thing here, it doesn't try to find the field on this list. It's finding the iterator. And we'll call this iter1 equals list1 dot begin. So that iterator is set to the beginning of list1. And we do the same thing, type name, standard, list t1, iterator, iter2 equals list2 dot begin. Now we're going to look at how we work with iterators, and we can do this in a number of different ways. I like to just use a simple while loop. We can iterate both of these with a while loop by saying iter1 does not equal list1 dot end, and iter2 does not equal list2 dot end. So what will happen here is if either of these iters reach the end of their list, this loop will stop. So it'll stop at the shorter of the 2. And now what we want to do is create, we need to create our result. I forgot to do that. Let's do a standard list, standard tuple t1, t2, result. So we're going to create a tuple, standard tuple t1, comma t2. We'll just call it tup. Now what are we going to put in here? We're going to use an asterisk to dereference iter1 from an iterator to its current item. But then we're going to advance the iterator. And then we're going to go pointer iter2 plus plus. So what this is saying is it's saying this dereferences it to an item, and this increments the iterator to the next item, but it returns the current item before it advances it, if you follow that. And that loads the iterator's position into that tuple for each of these two simultaneously. Puts them in there. And then all we say is result dot push back. Oops. Tup. And then down here we return result. So let's go over to main and see how this works. Well, we've got a couple of lists. We've got this int list and this int result. Let's mash them together. Let's go standard cout from zip result. So let's create that zip result that we're going to use up here. We're going to go standard tuple int. We'll call it zip result equals zip int. And the two lists are going to be int list and int result. Zip int list int result. Why is it giving me an error? Let me take a look here. Oh, that's right. Okay. No, it shouldn't care about that. What's it say? No suitable user item conversion, standard list int to standard tuple int. Oh, the standard allocator. That's right. Okay. List. Let me pause the video for a second because it doesn't seem to have that problem in my other project, and I don't know why that's doing that. So I'm going to pause the video for just a few minutes here and troubleshoot this, and I'll be right back and I'll explain whatever it was I did wrong. Okay, well, that was just a simple mistake. I had just standard tuple int here, and this zip produces a list of tuples of int, and that's why it wasn't mapping properly. So now we can come down here and 1 second, let me find the output thing here just to make sure. List zip. Yeah. Oh yeah, that's right. Okay. So now what we do, the standard for auto item. So it's a long type, and instead of typing out standard tuple int for item here, we just use auto. It works fine. We know it's a tuple of int. Zip result. So now we have each of our items that are a tuple. And how do we get these? We're going to go standard cout from pointer iter plus no from standard is on the wrong line. Get 0. I'll explain this in a second. From item from quote comma quote comma space quote from standard get 1 from item standard endl, and we should see these zip together now as tuples, and there they are. Zip result is 1, 3, 2, 6, 3, 9, 4, 12, 5, 15. So what this function did was took two lists, combined them together into a single list of tuples with all the data in there stored as tuples. This is a very useful concept and useful idea. Let me double check the time here on this video real quick. We are sitting at 30 minutes. So in the next video, we're going to do something else. Right now, this this set of functions here is great, except they only work on lists. They work on any element type of list, but they only work on the type list. What if we want to use these for vectors? I don't want to rewrite all these functions for vectors and all of them for some other container type. So in the next video, we're going to talk about templates. Templates are a very, very powerful system in C++ programming, in metaprogramming like we're doing here. So we're going to create templates that allow us to replace this list with a generic type like T here and have it build us a function for any container type that contains any type. So I'll see you in the next video. Thanks for watching. If you liked it, hit that like button. If you really liked it, hit that subscribe button, and I'll see you in the next video. Thanks for watching.